Once the clock diagram is completed, you can configure the frequency of each clock component. In this example, the reference clock here is 25 MHz. PLLs receive this reference clock as their FN, and based on their configurations, they generate various frequencies like 1 GHz, 800, 600, and 500 MHz. You can modify these configuration values to generate different frequencies. For example, changing the MDIF value of PLL-BB from 320 to 360, this will make 900 MHz. The output from the PLL-F out can be routed through the clock MUXes and dividers to generate different frequencies. For example, in here, .600 MHz clock can be selected through the MUX and divided by 2 to make 300 MHz clock. What's really important here is that the frequency of each clock component is visually displayed in the diagram. You can see the frequency of each clock node at a glance based on the current configuration. And whenever any setting is changed, for example, like a different dividing ratio or a different MUX selection, the frequency in the diagram is automatically and instantly updated. This is just one snapshot of clock configuration. There can be another frequency settings like this. You can select another one. You can see another clock frequencies on here. The challenge of clock system design is not just to create a single MUX or a single divider. As I experienced in mobile APs, there exist hundreds of clock MUXes and hundreds of clock dividers, and more than thousands of clock gates. What's really difficult is to ensure the data consistency across all these components, understanding how they are configured and keep everything in sync. Again, SOC is not about design, it's fundamentally about data handling. This feature to visualize clock frequencies can be used in many ways. For example, it can be used to create multiple DVFS levels. This can be done by creating multiple clock frequency settings. Even with the same PLL, it may have like 1 GHz in one level, but it can have another frequency in the another level. It's also useful during the sign-off for different corners like nominal, overdrive, and underdrive. And each of these configurations can be stored as different clock frequency setting profiles. One of the most valuable use case is clock debugging. Clock debugging is very difficult when it comes to the large-scale SoC. There are hundreds of clock MUXes and dividers and gatings, so no one ever knows how they are configured and what frequency they have right now in the silicon. In Clock Canvas, you can import CMU-SFR dump from T32. You can enter the debug mode. You can load the CMU dump data like this, and you can see how clock components are configured and what frequency each clock node has right now based on the real-time CMU-SFR dump data.